According to the VS-EPR theory, the electron pairs tend to occupy such positions in the valence shell so as to minimize the repulsion between them and maximize the distance between them. To understand the VS-EPR theory properly, we should know the term steric number. Now, what is steric number? Steric number is the number of electron pairs in the valence shell of a central atom. Now, these electron pairs may be of two types: bonding electron pair and lone pair. Bonding electron pairs is bonded with another atom apart from the central atom. Therefore, bonding electron pairs interact with two atoms. The lone pair electrons, on the other hand, interact with one atom only. Thus, the lone pairs repel more strongly than bonding electron pairs. First, we will try to understand the layout of bonding electron pairs only. When steric number is 2, the electron pairs occupy diametrically opposite positions and the molecule is linear. Bond angle is 180 degrees. When steric number is 3, electron pairs occupy the vertices of an equilateral triangle to minimize the repulsion between them. The shape is trigonal planar, and the bond angle is 120 degrees. When the steric number is 4, they occupy the vertices of a regular tetrahedron. The molecule is tetrahedral in shape and the bond angle is 109.5 degrees. When the steric number is 5, the shape becomes trigonal bipyramid. There are 2 axial bonds and 3 equatorial bonds. The bond angle between the equatorial bonds is 120 degrees. The bond angle between the axial and equatorial bonds is 90 degrees. When the steric number is 6, the shape is regular octahedral. The bond angle here is 90 degrees. Here there is no such distinction such as axial or equatorial bonds because the regular octahedron is a symmetric figure. Now we will try to understand the layout of electron pairs where the central atom has a combination of both bonding and lone pairs. Let the steric number be 5. There is a lone pair and 4 bonding pairs. Now the question arises, which position the lone pair will occupy, the axial position or the equatorial position? Since a lone pair is a stronger repeller, it will try to occupy a position from where it is repelled the least. Then only it can repel the most. In the equatorial position, it is repelled by 2 bond pairs only, whereas in the axial position, it is repelled by 3 bond pairs. So the lone pair always occupy the equatorial position. Since the lone pair does not contribute to the shape in this case will be seesaw. If there are 2 lone pairs and 3 bonding pairs, both the lone pairs occupy the equatorial positions and the shape is T-shaped. When there are 3 lone pairs, they all occupy the equatorial positions and the shape becomes linear.